Alright, hey everybody, and welcome to this free training. This is David, and today I'm going to show you how to increase machine safety without paying an arm and a leg, literally or financially. Now just to be clear, when we're talking about machines, we're talking about anything with moving parts. It could be equipment, tools, processes, etc. But in this training we're going to call them machines. So this is something that people often pay over $5,000 for me to come and teach at their companies, but my goal right now today is to get this training in front of as many people as possible. So I'm providing it to you for free. Now to get the most out of this, I need you to treat this like your life depends on it. Except that it might not be just your life. It might be your coworker, your friend, your boss, or even your child. So go ahead and clear the next 30 minutes of your day. Shut off your email, your Facebook, your cell phone, and get something to take notes with, because there's a lot of really good information in here. Now, I'm guessing that a lot of you have run across a machine that you think is unsafe or is being used in an unsafe manner. The first thing that I want to mention is that this is actually really common. The information on design safety reviews, unfortunately, is a very well kept secret. And sometimes that keeps you from the level of safety you would want or expect. Now, a lot of times a new product is launched or whipped up in the shop to be used for manufacturing, and it just gets thrown out there with the hope that people will use it correctly and nobody gets hurt. And here's another secret. Even though that sounds crazy when you say it out loud, this happens all the time. People have products that are not documented, have never had any safety analysis done, and they're just put into the market, put into use. And today we're going to show you how to avoid all of that. Because in most cases, the safety analysis wasn't skipped on purpose. It's usually not skipped because people, it usually is skipped because people don't know that they're supposed to do it. I know, I've been there. Now tell me if this is you. Often the safety officer is appointed, not because of their education, but because the old safety guy retired and they needed someone to help make sure things were being done safely. And so you got put in, even though it's not your background. A lot of safety officers get their start this way. Now, if you got a degree in environmental health and safety, you might have been educated on design safety reviews, and you might remember it well enough to implement it at your place of employment. If that's you and you're confident that you're doing design safety reviews and you're doing them correctly, this presentation probably isn't going to help you very much. But for most of you, design safety reviews are going to be either completely new or something that you have only heard about but don't really know how to implement. I get that. I've taken every class on product development at 2 different universities through both the engineering programs and the business programs. And guess how many times safety came up? Only once. And it was a 5-minute student presentation on design for safety, which said, hey, you probably should think about safety when you design things. Hardly sufficient training for people that are going to design aerial lifts, airplanes, construction equipment, and other heavy equipment and lifts where people could get injured. So that's what we're here for. You want to learn the design safety review process. You want to see your incident rates decrease, your insurance and accident related costs go down, and your coworkers or employees go home safely every day. And when that happens, you will see your job security increase because all of that happened on your watch. And I'm going to show you how to do that during this free training. So I have 3 goals. The first is to help you recognize that the only way to ensure that your machines are safe is through a design safety review. And you can do this on new machines that you're just building and putting into production, or you can do it on machines that you've been using for the last 50 years in your company. It doesn't matter, it works for both. The second goal is to help you understand that design safety reviews need to be part of your design process. And the third is to give you the framework, the know-how, the process to carry out a design safety review in your company. So before we go any further, let me introduce myself. My name is David Smith. I'm the Vice President of Alpine Engineering and Design, a product development and safety consulting company. I am a licensed professional engineer and a certified safety professional. The company has been consulting on design and safety for over 30 years. I personally have been doing this since 2006. So some of the companies we've consulted for are listed here. They have products and equipment ranging from thrill rides and zip lines to semi-trailers, oil and gas equipment, cranes, aerial lifts, and other types of manufacturing equipment. So we've had a broad range of experience with different types of equipment. And typically in our business, we're contracted by other companies or individuals for one of three things. The first thing is designing new safe machines or equipment. The second thing is analyzing other people's designs that are having problems or that they want checked before they release it. And the third thing is forensic engineering and expert witness work, which is analyzing accidents and figuring out what went wrong and why people got hurt and why things broke, and what could have been done better from the get-go. So one day I was analyzing an accident. A trailer had come detached from the truck that was towing it. The ball wasn't seated in the coupler, they hit a bump and it popped off. The safety cables that were supposed to keep the trailer connected, if this ever happened, failed almost instantly when the tongue hit the ground. And the family only knew something was happening when they saw the boat passing them in the left lane. The boat then went across the median into oncoming traffic. It hit a motorcycle and it killed both passengers, and then it hit a Nissan and it knocked it off the road down the hill into a creek. Luckily, all three of those passengers survived. And as I was going through what the company had done during their design process, specifically relating to safety, I was really disappointed by how little they had actually done. This was, one of the 5 largest trailer manufacturers, boat trailer manufacturers in the U.S. But I was even more frustrated with them because this crash and the deaths were totally preventable. There are laws that require that trailers have secondary attachments just in case the hitch comes off the ball, like happened in this accident. And so they put something on, but they never stopped to think about whether or not it would actually work. They just didn't know how. As I went through the process, the same process I'm going to teach you in just a couple of minutes, it was abundantly clear what would happen and how a simple design change could have completely prevented the crash. So I decided, as I was going through that instead of just doing this work for our products and after injuries have already occurred, that I would help other people and other companies learn how to conduct and implement design safety reviews before people get hurt and before they go through a huge multi-million-dollar lawsuit. So here we go. And here's a little secret. You don't have to wonder whether your product or machines are safe. You don't have to cross your fingers and pray that nobody gets hurt when they use it. And you certainly shouldn't be losing sleep over whether your workers are going to get hurt with the equipment they use. There's a little known step that should be in every design process, and once you implement it, it could mean the difference between the success and failure, not just of the product, but of your entire company. Now, only companies that implement this secret step can sleep well at night, knowing that they have done everything they can, and we're going to talk about that today. So, what is the secret step? It's called the Design Safety Review. Now, you might be asking yourself, what types of products need design safety reviews? Some things are pretty obvious, like a thrill ride, and other things are less obvious. Things that are simple. A lot of times people think it doesn't need to have a risk assessment or safety analysis done. That's probably what McDonald's thought about their coffee, at least until they had to pay nearly $3 million in damages after an elderly woman was severely burned. So if you have products and equipment without documented risk assessments, that show the risks have been reduced to an acceptable level and you want to change that, you're in the right spot. So there's 3 categories of people that I usually work with. The first category are engineering managers. People that have new equipment and they want to make sure the associated risks are acceptable. Or they need the product to be certified to a certain standard. The second group of people are safety managers. They have concern about the safety of different equipment used by the company employees, some that they've purchased for specific processes and some that they've made because they couldn't find anything to purchase. Or something that was made a long time ago that's just been used because that's how they've always done it. And the third category are executives that like the reduced liability of having an outside company analyze and report on the risks associated with their equipment and whether it's safe for its expected use. So, for a couple of examples, one client we worked with had a lift that they had designed and used for loading and unloading rolls of film into a label machine. And the lift worked really well for full rolls and allowed them to take the roll off the storage rack, transport it over to the machine, and insert the roll into the machine. However, sometimes they used the machine for a small batch that didn't use the entire roll. And when this happened, the lift lacked sufficient height to remove a partial roll from the machine. In these situations, the operators manually lifted the rolls, which usually weighed between 100 and 200 pounds, out of the label machine. And it was a pretty awkward lifting position. And because they take safety seriously, they realized that they needed to do something. If someone hurt their back lifting the rolls out, they could be looking at $100,000 surgery, not to mention the pain and suffering that a person might have to endure for the rest of their life. We were able to help them with the design of a new lift that had increased range of motion, fit the available working space, and also included a hazard analysis, risk assessment, and calculation package to document that the machine had the requisite strength and reduce the risks associated with the process of loading the film rolls considerably so that all the risks were acceptable. In another example, we were working with a company that makes large valves. The manufacturing process included a turning step on a lathe. And to ensure that the valves were secured in the lathe, the operators had installed cheater bars on their wrenches, which is a makeshift length extension that allows them to apply more torque and tighten it tighter. The company was worried about the safety of the cheater bars, not wanting any of them to break with the employees pulling on them as hard as they could. The management and employees had a disagreement about what to do, and so they called us. After walking through the hazard analysis process, it was clear that both management and the employees had recognized an important hazard. If the valves were not tightened appropriately in the lathe, they could come out when spinning at high speeds, with the ability to cause catastrophic amounts of harm. But if the cheater bars broke, given the surroundings and equipment, such a failure could also lead to serious injury. So we came up with a way to test and mark the cheater bars to ensure they had sufficient strength for their application. Interestingly enough, most but not all of the current tools passed the test. Those that didn't pass were disposed of, and those that did pass were marked and documented and returned to use. So what is a design safety review, and how can we implement it in our companies? Let's get into it. According to ANSI, design safety reviews have 13 steps. I'm going to explain each step for you as we go through them today. Now, the first step is management direction. Management should be involved in determining when, where, and how design safety reviews are performed. They should outline the roles, the responsibilities, and accountabilities for those involved. Most managers realize that time spent on safety directly impacts the bottom line, even if it looks like an investment or a cost up front. So get the management involved. The second step is to select a risk assessment technique. Every project is different, and the proper technique depends on the complexity and criticality of the project and the experience of the team. Some of the more common techniques are preliminary hazard analysis, job safety analysis, checklist analysis, what-if analysis, hazard and operability analysis, failure modes and effects analysis, fault tree analysis, and a management oversight risk tree. So the third step, and this is where we really start getting into the meat of it, is to establish the parameters of the analysis. This is the who, what, why, when, and where. So first we need to determine what task, material, system, process, or equipment is going to be analyzed. Sometimes you'll need to do multiple analyses for a piece of equipment, and then the process that it's part of. This is where we define what the particular analysis will cover. Next, we need to define who is going to be using the equipment. And there may be multiple who's, and we need to consider them all. Do they have special training? What is their education level? How long have they been doing this? How often do they use this particular machine? For example, if you're designing a piece of workout equipment, are you designing it for Tom Brady's personal trainer? Or are you designing it for Bob the January Warrior using it at the local recreation center? Next, we need to address the how. How are the people defined above going to use the equipment? Is it standard operation? Is it startup? Is it maintenance? Is it loading or unloading? All of these things can present different risks and different hazards. And so we need to specify which ones we've looked at and which ones we've considered in the analysis. Next, we want to look at when the equipment will be used and when the task will be accomplished. Is it seasonal? Is it snowing outside? Is it being used in the snow? Is it used on the night shift? There's a lot of different things that you can consider with the when. And the final parameter to consider is where it will be used. Is it a loud area? Is it busy? Is it high traffic? Or is it in the back corner of an empty shop? Any of these can introduce new or particular hazards that need to be addressed in the next step. So step 4 of the design safety review is to anticipate or identify the hazards. So to do this, we use the assessment techniques identified in step 2 to determine what aspects of the technology produce risk. We can use intuitive engineering, consider the potential for energy release, and review codes, regulations, and standards. Reviewing the standards is particularly important. As I see it, this is how you stand on the shoulders of giants. The standards are written by people who are familiar with this type of equipment, who have seen all the crazy things that people are going to do with it and all the ways that it can be used and misused. So if you don't know what codes, regulations, and standards are applicable, look at the relevant trade associations, OSHA, ANSI, ASTM, or other organizations particular to your industry. Make a list of all the hazards your team came up with, write them down. Even if you don't think it's serious or that it probably won't ever happen, if you thought about it, write it down. The documentation is important because you need to show everything that was considered in the analysis. Alright, so the next step is to consider the failure modes. So in step 4 we considered how people are going to get hurt using it properly without things breaking. And in this step we need to consider how people might get hurt if something breaks on the machine. So we need to look at how people are going to use it and misuse it, and you need to consider reasonably foreseeable uses and misuses. You can also consider what controls are in place to mediate the failure modes and how easy they are to maintain. Do those controls introduce new hazards, and how easy are they to bypass or defeat? And would someone be motivated to do that? Is it a lot easier to use the machine without the safety guard, or have you made it easy to use both ways? Usually this is done with a failure modes and effects analysis. The more thorough you are, the better the safety review will turn out. So don't be afraid to dive deep. Alright, so risk is always a combination of how bad a hazard or failure could hurt someone and how likely they are to get hurt. The terminology that is typically used is what is the severity of consequences and the probability of occurrence. Determining these levels is what you do in the next 2 steps. So step 6 is to determine the severity of consequences. Consider how long recovery will take if someone gets hurt, and the value of the property or equipment damaged, and the time that business will be interrupted. Rate each hazard and failure that were discovered in the previous steps. So next we determine the probability of occurrence. Consider how often the task is performed, how long the people are exposed to the hazard, and how many people are exposed. For example, in a mechanic shop, the probability of a wrench slipping off a bolt is probably a frequent probability, while the probability of a lift falling and a lift failing and a car coming down on top of a worker is much lower. So now that we have identified the hazards and failure modes and determined the probability of occurrence and the severity of consequences, we're ready to define the initial risk for each hazard. We can define risk with the matrix shown below, with risk ranging from low to medium to serious to high. When risk is too high to be acceptable, we can take steps to reduce the risk. And there's a 4-part framework for doing that, and that's step 9. So ideally, risks can be designed out. That's the best solution, so that the hazard no longer exists and no one is subjected to it. While this is often possible, especially if considered in the design process, it's not always possible to design out risks while maintaining the functionality of the machine. So the next best thing would be to guard against the risk. This would be making it more difficult for the operator to expose himself to the risk. OSHA provides a lot of information on how to properly guard different types of machines and are a great resource when trying to do this correctly. If the hazard can't be designed out or guarded against, then warnings need to be provided. Now, research has shown that warnings are less effective at changing operator behavior than guards, but they can still increase awareness. The lack of proper warnings is also a very common argument that attorneys like to make in the event of an injury. The last way to reduce risk associated with a hazard is to provide administrative controls, supervision, training procedures, etc. So ideally, the hazards can be designed out or guarded against, but sometimes warning and administrative controls are the best we can do. So after we apply this 4-step framework and reduce the risks associated with the hazard, it's very important to reassess to make sure the risk has been reduced to acceptable levels and that new hazards haven't been introduced. I can't tell you how often this happens. Just the other day I saw someone who created an extension for a ladder that they claimed would let you stand on the top step because it kept your feet from falling off the edge and gave you something to lean up against. So they were trying to alleviate the hazard of people falling off the top of ladders. Unfortunately, what they had not given any thought to was how that changed the center of gravity of the system and how easy it was to tip the entire ladder over when you're standing on the top. So by reducing one hazard, they introduced a new hazard, which was just as serious, if not more, than the first one. So don't skip this step. Follow the process. It's there for a reason. Alright. So now that we've done our best to reduce the risks, someone needs to decide if the risk has been reduced to an acceptable level. And what acceptable is can be determined by your company. Typically, moderate and low risks can be decided or accepted by lower management, while temporary acceptance of higher risks is a decision that needs to be made by top management. Now, hopefully the risk reduction has been successful in reducing everything to a lower medium risk, which will generally keep everybody very safe. So the next step is to document the results. We're almost done, so hang in there with me. This is a really important one. This is usually done throughout the entire process. You don't do everything and then document it at the end, but you do it as you're going through the process. You need to document who was involved in doing the analysis, what their qualifications are, what their job titles are, which risk assessment methods were used, what the parameters of the analysis were, what hazards were identified, what the risks derived from those hazards were, what control measures were taken, and any other relevant information. I like to have this document a packet for each piece of equipment that's used. If it's shop-made equipment, it's probably going to have to be a little more detailed than if you purchase something. But even purchased equipment will need to be analyzed as it is being used in your company, because sometimes it's not the right piece of equipment for the job. And the last step, step 13, is to follow up on the actions taken. We need to make sure that the changes that have been implemented are not just implemented on paper. It's not just something that we wrote down, but we need to make sure that it actually makes its way into our process or into our machine, so that we've certainly achieved that acceptable level of risk. Now, the result of executing this correctly is that A, your product will be safer for the people using it. B, you will have a better understanding of your equipment and how to explain and teach its safe use to operators. C, your productivity will be improved. And D, in the event that there is an injury, you will have a documented risk assessment for the product proving that you took every effort to make sure the product was safe for its intended purposes. So here's a couple more examples of where design safety reviews really made a difference. So a company we were working with was making a new enclosed trailer. The trailer had 3 levels, a bottom, a middle, and a top. Go figure. The top floor had enough headroom to stand reasonably comfortably, but the lower and middle floors only had about 4 feet of clearance. Now this company had come up with a really neat way to make the middle level movable so you could get in and stand up to clean the trailer out for both the middle and bottom floors, which had to be done after every load. You had to go in there and spray it all down with a hose. So we walked through the process with them, just the same process that we just went through. We defined and identified several design changes that would not only increase safety, but also that would increase the usability and overall functionality of the whole trailer. We helped them get all their documentation in place, and this was right before all of their sales exploded, so it was perfect timing. Another example, thrill rides are meant to scare people. Obviously, they require high safety standards. Before a ride can be installed, every component has to be analyzed to make sure that it has sufficient strength. Risk assessments and FMEAs need to be done. They're required by most installation sites. And we have consulted on over 100 different thrill ride installations that have carried hundreds of thousands of passengers safely. So something that we're very familiar and very comfortable with. Now, clearly, not everything has the rigorous standards of thrill rides, but that doesn't mean that a design safety review is not just as important. For example, this is a cleaning tool that we worked on that attaches to the end of your broom. So you can flip your broom over and remove stuck Cheerios or stickers from your floor as you're sweeping it, so you don't have to bend over. And the design safety review led to rounded corners and a thick side guard around the scraping edge to prevent injury or damage from occurring. And when the broom falls over, because that happens all the time, no one's going to get hurt. So simple changes that come out of the design safety review can increase the product safety significantly. Alright, so who's ready to implement design safety reviews for all of their products, machines, processes, and equipment? Hopefully this free training has given you a good starting place so you can really dig in and get going. But we have noticed that even with training, a lot of companies still like to have someone walk them through the process, at least the first time. It does take a different mindset to go from how do I make this work to how is this thing I've been working on for 4 months going to hurt people? So if that's you and you're someone that would like to have someone walk you through a design safety review and you'd like a little more instruction or guidance on how to use some of the risk analysis techniques or the hazard assessment techniques, if you want the benefit of hiring a third party for a design safety review, we are currently looking for a couple more excellent clients. The kind of clients that we can help get the kinds of results that I've shared with you earlier. That's why for a limited time I'd like to work with you in a safety strategy session to see if you meet the following criteria. So the people that we like to work with are companies that realize that safety and risk reduction is important, but really don't know where to start. Or companies that are serious about safety and want to make sure their I's are dotted and their T's are crossed. Companies whose products need to be analyzed and certified before they can be sold and used. Or people who prefer to have the added benefit of having a third-party certified safety professional and registered professional engineer audit their equipment and machinery and provide feedback on its safety. So who is this not for? This is not for people who make excuses and justify unsafe behavior and the use of unsafe machines. We're also not looking for people who are stuck in information gathering mode and are not prepared to actually take action or get results. And we're also not looking for anyone who views safety as an expense rather than an investment that leads or that adds to the bottom line at the end of the day. Now, knowing that we're a good fit is crucial because I like to get all of my clients' results and work with them for the long term. And to do that, I need to help them make their machines safer. And the truth is that sometimes some people we can't help. And if that's the case, I will be 100% upfront with you and suggest somebody else or an alternative. I'm only looking for people who are a good fit and I'm certain I can get results for. So how does the process work? The first step is to complete an application for a private strategy session below. This application is necessary to determine that 1, I can help you, and I'm the best person to help you generate the results you want, and 2, that you're ready to step up, commit, and take action to do the required work to generate the results. Now once I receive your application, you'll be able to schedule a time with me to conduct your strategy session. This is where we will really start working together to figure out what you want and how to make it happen in the fastest time possible. And then at the end of the call, which has all been free so far, one of 2 things will happen. Either you'll be a good fit and I will extend an invitation to work with me as one of my clients, or if it's not a good fit, that's totally okay too, and there's no hard feelings or obligations or anything. And hopefully we can find someone that is the right fit for you. Either way, you'll receive an incredibly valuable safety strategy session and will walk away with newfound clarity as to where you are right now and what's holding you back from achieving the results you want. So that together with the exact steps necessary to take action and break through your barriers. It could possibly be the most valuable 30 minutes you invest in your business this year. So go ahead and complete the application now and see if we're a good fit for doing business together. Now, I do have to warn you, I'm only one person and I do work with a small group of registered professional engineers and certified safety professionals. But our resources are limited. We can only work with a few clients at a time to get them the results that they need. So with that being said, please understand that this window of opportunity won't be available forever, and the longer you wait, the longer your lead time may be. What I've found is that those who have the ability to make decisions and act quickly are the most likely to follow through and get the results that they want or need. So if you made it this far and you feel like this is right for you, go ahead and apply right now to see if you qualify. And then go ahead and follow the instructions on the next page. You can just click the button right below this video. Thanks, I hope this was helpful for you, and we look forward to speaking with you on your safety strategy session.